Okay, so angles formed by secants and tangents. A quick little review. First of all, there are always 360 degrees in any circle. So, if one portion of my circle has 200 degrees, the remaining portion of this circle has to have 160 degrees. And the other quick review is that any central angle has the same degree measure as its corresponding arc. So in this case, x also equals 160 degrees. Okay? Another example. One of these arcs has 140 degrees. The other arc has 170 degrees. Together that makes 310 degrees. So that means that this remaining arc here must have a measure of 50 degrees. Now this isn't something we've talked about much, or maybe even at all, but you got to be careful here because it's the central angle here that would also have a degree measure of 50 degrees. This x is not a central angle. That angle is over on the arc. And the rule of thumb there is that let me go ahead and erase what I already have on the inside here because that is not what we're looking for. If you have an angle on the circle and you know the degree measure of the arc across from that angle and it's on the circle, we'd simply take the degree measure of the arc across from it and cut it in half. So in this case, x is 25 degrees. Okay? So once again, an angle on the circle is equal to half of the arc that is across from it. Okay, so as we continue on here, I actually have that theorem written on this slide. Looks like it got slid down a little bit, so let me move it up so we can actually see it. If we have a tangent and a secant, now first of all, as a little refresher for you, a tangent is a line that only touches the circle in one place, whereas a secant is a segment or a line that touches the circle in two places. If you have a secant and a tangent intersecting together at the point of tangency, which would be this right out here, okay, then the measure of each angle formed is half of the measure of its intercepted arc. Okay, so once again, because this angle here is 30, if I want to know the measure of the the measure of the arc that is across from it, I'm just going to take 30 and I'm going to double it. So that angle is 60 degrees. The angle is half of the degree measure of the arc. Okay, so let's look at another example here. Same idea. All right, I know that a secant and a tangent, which is what I have here. I have one tangent, which is this line here, and I have one secant, which is this one here. I know that if I take my angle, which is right here, and I essentially double it, that's going to be the measure of the arc. Okay, because the arc, the angle is half of the arc. So if this is 89 degrees, I know that this here, this arc, is, let's see, 90 times 2 would be 180. So this is 188 degrees. So I can take 11x plus 2 and set that equal to 188. Okay? Essentially, I'm taking and I'm doubling the angle to equal the arc. So here I would just subtract 2 from both sides. So I have 11x equals 186. Divide both sides by 11. And that comes out to about 16.9. and some change. Okay, a couple more of these. What about if I have two secants? Because that's what we have here. This is a secant and this is a secant, and they're meeting on the inside of the triangle. Well, we also have a theorem for that. And that theorem is if two secants intersect in the interior of a circle, then the measure of the angle formed is half of the sum of the measures of the arcs that are formed. So one of my arcs is right here. The other arc that is formed is right here. Okay? My formula says one of those inside angles is half of arc plus arc. So another way I can write this is that angle equals half arc plus arc. Well, my angle is equal to half of 70 plus 30, because those are the two arcs that are created. So that's half of 100, and in this case, x is equal to 50 degrees. Okay? And then one last of these. Now these are not super hard, it's just that you have 4 different ones to keep together. So now we have two secants. Okay, I have a secant here, and I have a secant here. Or if you also had a secant and a tangent, or two tangents, in this case it's two tangents, sorry, this is two tangents, the measure of the angle formed is half of the positive difference of the measures of the intercepted arcs. Here's what that means in layman's terms. Here's one arc that is created, and then the tangents hit, and then we have the remaining arc that is right here. Okay, you have a minor arc that's red and a major arc that's blue. Okay? If I look at the fact that the red arc is 150 degrees, and I think about the fact that I have 360 degrees in any circle, if I subtract 150, what I find is that this is a 210 degree arc. Now that has nothing to do with solving this yet. All I did was I found the other arc. Okay? Then, now I'm looking for this angle out here. This angle right here. That's what I'm looking for. Let me go ahead and get rid of that because I just covered up the fact that I was looking for x. I covered up x. Let me cut that out of there. So what I'm looking at now is the angle being half of arc minus arc. Just do the bigger minus the smaller because we want to know the positive difference. So I'm going to do 1/2 of 210 minus 150. So that's half of 60, which is 30. So I know that this right here is a 30 degree angle. Okay? So let's wrap all this up. There's 4 different ones you're going to see. You're going to see if the arc is at the center, well, that's easy one because it's the exact same. That's like when we have a circle like this. If this is 10, this is 10. We have an angle on the circle. That looks something like this. Well, if this is 10, then this over here is 20 because the angle is half of the arc. And then the other two, angle inside looks like this. Angle outside looks something like that. Okay? For this one, we use arc plus arc. For instance, if I'm trying to find this angle, these are the two arcs I'm adding together, then dividing by 2 or cutting it in half. And down here, I don't know, I lost my minus sign there. But if I'm looking for an angle down here, I'm doing arc minus arc.